So this video is over my analysis of the unknown that I identified in the organic chemistry laboratory. I chose to do unknown AC, which was a yellow crystalline solid. I started by testing the melting point analysis of that compound. I did this by placing a small amount in a capillary tube and then placing that capillary tube into the Digimal apparatus and observing the compound until it melted. That melting range was observed to be 83.5 degrees Celsius to 88.9 degrees Celsius. After this, I tested to see if the compound was soluble in water, so I took a small portion, placed it in an okay amount of water. It did not dissolve, barely any, which is predicted after knowing the identity of the compound that it would not be water soluble. Next, I made a KBr pellet of the compound by taking a small amount of my solid sample and taking a mortar and pestle and mixing it homogeneously with solid KBr compound. Then I compacted that into a small pellet that was just very thin, just barely even thicker than a piece of paper. And then I placed that into the spectrophotometer and I obtained the IR graph that you will see later in this experiment, which helped me to identify functional groups and other parts of the compound, which was the biggest part in helping me to identify my unknown. So those are the way I've tested. Let's take a look at the identity, or at the structure and some of the properties of this compound. You can see the compound on the board, 9-fluoroenone, with a melting point 83.50 degrees Celsius, molecular formula C13H8O, and then you see the molecular weight, 180.94 grams per mole, right there. And then you also can see where we've got the functional groups listed. There is 1 ketone and 2 phenyl groups, which you can see in the molecule. This here comprises the ketone of the molecule, and then this and this right here are the 2 phenyl groups. All 3 come together to make up the molecule. This molecule is what I have determined my unknown compound to be due to the melting point analysis you see there and the IR spectra that we will go over now. This here is the IR spectra of the KBr pellet that was run on the unknown compound. You can see an OH peak here that indicates an OH group is present. This is probably due to contamination, as analyses of everything else in the remaining IR graph and spectra, it's seen that this compound is a 9-fluoroenone, which does not contain an OH peak. You do, however, see an sp2 hybridized carbon-hydrogen bond from this peak right here. Normally, that's in the range of 31 to 3,000 centimeters to the -1 range. You see here it is a little bit right in that range, so it does fall in perfectly. Some of the others, such as this ketone carbon-oxygen double bond peak, it's around the 1651.76. Normally they're down in the 1750 to 1705 range, but that was probably thrown off more likely due to the contamination, I guess, by water, which is what is believed to cause this OH group, as the water contaminated the sample. You also do see 2 peaks here, one here and one there, and they both indicate benzene rings in the compound, which is seen in 9-fluoroenone, but the 2 phenyl groups that is attached to the carbon that is a part of the ketone. So if I had to redo the experiment, I would make sure there was no contamination when running the IR spectroscopy, that was used on the IR spectrophotometer and the computer equipment that was used to obtain the graph. But I would make sure there was no contamination, as we seen that OH peak on the graph that wasn't supposed to be there, because there's no oxygen-hydrogen bonds in my compound, nor in the compound I identified it as. So again, that's what I would make sure that didn't happen, so my IR spectra would be almost perfect, hopefully. So anyways, so you've seen the IR graph of my unknown, and you've seen some of the structure of non-fluorone and some of the properties, and so hopefully you can see why I chose that as the compound that I analyzed. They matched up very well with the melting point. Neither one of them were soluble in water. And the IR graph indicated a lot of the functional groups that we see in non-fluoronone. And I hope you enjoyed this video. Thanks. In making this video and during my lab, I referenced a few different sources. One of those was the PNAS How To Making the Connections for Organic Chemistry Lab Techniques. I referenced this on techniques for the IR spectra, and it also gives details on melting point analysis. So that was a big part and a big help in my experience, and I referenced that. I also referenced the textbook by J.G. Smith, Organic Chemistry, the 3rd edition. This helped me just to identify ketones, or functional groups, to know what they are, certain things like that. You know, it talks about properties of molecules, and that was a big help, so I referenced that. And our instructor, Dr. Chris Mullins, also provided us with a handout, and that had a list of compounds on it for us to, or as possible unknowns that we obtained, and so I used that also in addition to the other references to help me identify my compound.